Hello, and thank you for being here today. My name is prof.Nevyana, and together with my co-author Theodor Daskalov from Sofia University St. Clement Ohridsky, I am pleased to present our study entitled Gamification as a Communication Amplifier for Campus Water Sustainability, Survey and Water Meter Evidence from Filtered Water Pilot. This research explores how communication, supported by gamification and objective water meter data, can encourage more sustainable water consumption within a university campus. The central idea of our research is that gamification should not be viewed as the main driver of behavioral change. Instead, we see it as a communication amplifier. Our pilot suggests that people are much more likely to choose sustainable behavior when filtered water is visible, easily accessible, and trusted. Communication explains why this choice is important, while game-like activities help maintain attention, encourage participation, and provide feedback. To strengthen our findings, we combined survey responses with objective water meter readings. Although this is a pilot study conducted at a single faculty, using both subjective and objective evidence provides a richer understanding of behavioral change. Water sustainability is not only a technical issue but also a behavioral challenge. Universities are ideal environments for studying this because they combine daily water consumption, educational activities, and measurable infrastructure in one place. Many people already understand that water is a limited resource. However, awareness alone rarely changes behavior. People also need a practical alternative that is convenient, trustworthy, and easy to adopt. Our study, therefore, focuses on reducing the gap between environmental awareness and everyday action. The existing literature shows that changing behavior requires more than simply providing information. We built on the CEOMB framework, which explains behavior through three interacting factors: capability, opportunity, and motivation. Previous studies also show that refill stations are more successful when they are combined with awareness campaigns and reusable bottle programs. Research on gamification has produced mixed results. Its effectiveness depends heavily on the context and how it is integrated into real-life activities. Based on this literature, we argue that gamification works best as a lawyer that reinforces an already available sustainable choice rather than replacing it. This idea is reflected in our conceptual model. The first component is the filtered water infrastructure, which creates the opportunity for sustainable behavior. The second is communication, which explains the environmental importance of choosing filtered water and builds trust in the system. The third component is gamified engagement, which motivates participation through interactive activities and feedback. Finally, water meter data provide objective evidence that helps evaluate adoption and improves future communication. Importantly, our model does not claim that gamification alone causes behavioral change. Instead, all four components work together. Instead of testing strict hypotheses, we formulated three research questions. First, we wanted to understand the attitudes, barriers, and motivations that shape people's willingness to use filtered water. Second, we examined how participants perceived both the filtered water infrastructure and the accompanying communication and gamification activities. Finally, we ask what additional insight objective water meter data could be provided beyond self-reported survey responses. Because our study was conducted at a single site without a control group, we focus on identifying meaningful behavioral patterns rather than claiming causal relationships. Our study was conducted at the Faculty of Economics and Business Administration at Sofia University through the initiative called Drop-Off Significance. The project introduced filtered drinking water stations and combined this infrastructure with communication materials, public events, participatory activities, and gamified engagement. The practical goal was to encourage students and staff to replace bottled water with filtered tap water and to increase the use of reusable bottles. Rather than relying on a single intervention, the project integrated infrastructure, communication, participation, and feedback into one coordinated sustainability initiative. This slide presents the timeline of our pilot. We began with a baseline survey in January 2026 involving 192 participants to understand existing attitudes and behaviors related to drinking water. The filtered water stations were installed in April, followed by the main communication and gamified activities in mid-May. A follow-up survey with 131 participants was then conducted over the following 15 days. Throughout April and May, we also collected daily water meter readings, allowing us to compare behavioral trends before and after the intervention. To strengthen the reliability of our findings, we use three complementary sources of data. The baseline survey measured participants' initial attitudes and readiness for behavioral change. The follow-up survey captured their perceptions after the intervention. Finally, daily water meter readings provided objective evidence of actual filtered water consumption. Our analysis relied mainly on descriptive statistics, selected Spearman correlation analysis for ordinal variables, and interpretation of aggregate water meter data. Because most survey questions use single-item measures, we intentionally did not apply structural equation modeling or reliability testing. The baseline survey included 192 respondents, and almost 80% of them were students. This reflects the composition of the faculty community and makes the sample highly relevant for evaluating a university-based intervention. At the same time, we acknowledge that the findings cannot automatically be generalized beyond these specific academic settings. Before the intervention, participants already demonstrated strong environmental awareness. They rated very highly the statement that water is a limited resource, and they also expressed a strong sense of personal responsibility for sustainable water use. Another important finding was that more than 83% agreed that the location of filtered water station is crucial. This confirms that that awareness alone is not sufficient. People also need convenient access before they are willing to change their everyday habits. We also explored what motivates or prevents people from choosing filtered water. The strongest practical motivator was simply having accessible filtered water available. In contrast, gamification itself was selected by relatively few respondents as a primary motivation. The correlation analysis also revealed a clean pattern. Participants who considered bottled water more convenient were significantly less willing to use filtered water. This finding reinforces one of our main arguments. Infrastructure is the essential enabling condition, while communication and gamification can only amplify behavior when the sustainable option is already practical and convenient. After the intervention, all follow-up respondents reported that they had noticed and used the filtered water stations. This indicates that the installation achieved excellent visibility across the faculty. Furthermore, filtered water became the main reported source of drinking water for more than 3/4 of respondents, while bottled water represented only a relatively small share. Although this may partly reflect self-selection in the follow-up sample, it nevertheless demonstrates strong acceptance of the new infrastructure. The follow-up survey also suggests meaningful behavioral changes. Nearly 60% of respondents reported drinking filtered or tap water significantly more often after the intervention. Almost half stated that they purchased bottled water significantly less frequently. In addition, over 70% reported using reusable bottles regularly. These results should be interpreted carefully because they are based on self-reported data rather than paired individual measurements. However, together they provide consistent evidence that the intervention encouraged more sustainable drinking water habits. This slide focuses on participants' evaluation of the communication activities. One of the strongest findings was that respondents appreciated measurable feedback, particularly the visualization of water consumption through meter data. This helped make the environmental impact more tangible. The game elements were also positively received, with nearly 78% of participants evaluating them favorably. These results suggest that gamification was valuable not because it directly changed behavior, but because it increased engagement and made participants feel that their individual actions contributed to a visible collective outcome. Besides the survey results, we also collected objective evidence through daily water meter readings. The total volume of filtered water increased from 4.53 cubic meters in April to 10.7 cubic meters in May, representing an increase of more than 136%. The average daily consumption more than doubled during the same period. Although April was already a transition month following the installation of the refuel stations, these measurements provide an objective behavioral indicator that complements the self-reported survey findings. Looking at the broader consumption patterns, filtered water use increased much more rapidly than overall faculty water consumption. During the 2-month period, more than 15,000 liters of filtered water were dispensed. To make this result easier to communicate, we expressed it as the equivalent of approximately 15,000 1-liter plastic bottles. Of course, this is only a communication indicator based on an assumed one-to-one substitution, not a direct measurement of avoided plastic waste. Taken together, the evidence supports one central conclusion. Successful campus water sustainability depends on the interaction of 4 elements. First, infrastructure makes the sustainable options available. Second, communication explains why the behavior matters and builds trust. Third, gamification increases participation, maintains attention and provides motivating feedback. Finally, objective water meter data make behavioral change visible and measurable. Our findings therefore suggest that gamification is most effective when it supports an existing sustainable system rather than trying to create behavioral change of its own. Like every pilot study, our research has several limitations. The baseline and follow-up surveys were not paired, meaning we could not track changes for the same individuals. The follow-up sample was self-selected, and we did not include a control group for comparison. In addition, the water meter data covered only 2 months, and we did not adjust the results for daily building occupancy. For future research, we recommend a stronger experimental design, including paired pre- and post-intervention surveys, a longer observation period, occupancy normalization, a control site, and additional indicators such as bottled water sales or plastic waste. These improvements would allow future studies to make stronger causal conclusions. Thank you very much for your attention. To conclude, our study suggests that sustainable behavior is most likely to emerge when convenient infrastructure is combined with effective communication, meaningful participation, and objective feedback. We hope that this pilot can contribute to the development of more sustainable university campuses and inspire future research in this field. Thank you, and we will be very happy to answer any questions.